In section 9.4, we're going to learn a third method for solving systems of linear equations called linear combination elimination. Linear combination elimination is a method used to solve systems that are not easy to solve by substitution, which was the method that we did previously. Now, what makes a system easy to solve with substitution or not easy to solve with substitution? Because we're going to want to use substitution in ones that are easy to solve by substitution and linear combination elimination in systems that are hard to solve by substitution. This first system is an example of a system that is easy to solve by substitution. And the reason it's easy to solve by substitution is because one of the equations in the system has one variable that's already alone. Having that one variable alone in the first equation makes it really easy to solve that equation for x. However, the second example is harder to solve by substitution. And that's because there are no variables alone. Every single one has a coefficient. So this one is hard to solve by substitution because every variable has a coefficient. In this section, we're going to look at how to solve systems of equations of the second type, ones where every variable in both equations have a coefficient. So here's our first example of a system of linear equations which we're going to solve using linear combination elimination. So the first step in linear combination elimination is to combine the two equations. Now the way that we are going to combine the two equations is using addition. So what we're going to do is literally make this into an addition problem and add the two equations vertically. So when we add vertically, what's going to happen is, remember, we're talking about going up and down. We're going to add the x's, so we're looking at it this way. We're adding these like terms together, the x's, and that gives us a 6x. And then we're going to add together the y's. And what happens here is because the coefficients on the y's are opposites, so we've got a +2 and a -2, these are actually going to cross out. And when they cross out, the y's are getting eliminated. So this is where the elimination part of the name of this method comes from. Because when we add them vertically, if we've played our cards right, we should get one of the variables to be eliminated. So we don't have anything there, and then we have our equal sign, and then we add together the 7 and the 1, and we get an 8. So when you combine the two equations by adding them vertically, you should eliminate one variable to create one equation in one variable. When you combine your two equations, it's really important that one variable gets eliminated and you have one equation that has one variable left in it. Once we've got our new equation, 6x equals 8, we're going to just solve this to find the value of x. So I'm going to divide both sides of the equation by 6, and we'll get that x equals 4/3. So now we're half done. We have one part of our solution. So our second step is going to be to solve this new equation to find one variable. Once we are done solving that equation to find one variable, this linear combination elimination problem becomes one of our old substitution problems from section 9.2. Because when we have the value of one variable, we just need to plug it in to one of our original equations to find the value of the second. So now we're going to plug x into one original equation to find the value of y. So you can pick either original equation. It doesn't matter which one. I think I'm going to pick the first one, the 3x plus 2y equals 7. So I'm going to use the 3x plus 2y equals 7 equation to use my x to find y. So what I'm going to do is I'm taking this 4/3 and I'm plugging it into this original equation for x. So I'm going to have 3 times my 4/3, so I plugged it in for x. This is the same thing we did in the substitution after we had the value of one variable. And I'm going to add 2y, and that equals 7. If I multiply the 3 times the 4/3, the 3's cancel out, leaving me with just a 4 plus 2y equals 7. Subtract 3 on both sides, and now I have 2y equals 4. Divide by 2 on both sides. Oh my gosh, I just noticed I made a terrible mistake. You're probably wondering, Miss Santilli, what are you doing? I subtracted 3 when I really meant to subtract 4. Let me erase that. Who knows what I was thinking of just there. So I'm going to subtract 4. So then I'll have 3 over here divided by 2. So that means that y equals 3 over 2. So at this point, we now have the value of both variables. We've got x and y. So we can write down our solution. We can say, as usual, that our solution is a point, and that point is the point 4/3, comma, 3/2. So we had 3 steps. First, we combined the 2 equations by adding them vertically. We made one equation with just x in it. We solved that new equation to find one variable. In this case, the variable that we found was x. We could have found y first, though. Then we plugged our x into one of our original equations to find y. And you can choose which original equation to pick. Now that we have our solution, we're just going to check to make sure that it's right. So we have to check to see, is 4/3 a solution to 3x plus 2y equals 7? And what we're going to do is we're not going to check it in both equations, because we already know that it works in this equation, 3x plus 2y equals 7, because we solved there. We're going to check it in the second equation. So we'll check it in 3x minus 2y equals 1. And so as a rule, we're always going to check our solution in the equation we didn't use to find the second variable. So here's our check. We take 3, and we've got to multiply it by 4/3 because that's our x. And then we're going to add 2 times 3/2 because that was our y, so 3 over 2. And we've got to see if that equals 1. So when we multiply 3 by 4/3, the 3's cancel out and we get a 4. And when we multiply 2 by 3/2, the 2's cancel out and we get, oh, I'm sorry, we should be subtracting here. I miswrote. We should be subtracting. So we're going to have 4 minus 3, and that does equal 1, which is what we want. So we're right. We know that this is going to be the solution to our equation. Now, if we take a look at another example, here's a new system of linear equations, we see that we have a problem with using linear combination elimination. You see that neither the c or the d have coefficients that are opposites. So if we add them together, neither one of them will cancel out to eliminate one of the variables. So since neither c or d have coefficients that will cancel each other out, what we're going to do is we're going to change one of the equations so that they will. So what we're going to do is we're going to multiply one of the equations by a number that will result in either the c or the d having a coefficient that will cancel out with the coefficient of the same variable in the other equation. So here's what I mean, if that sounded confusing. What you want to do is you want to multiply this, in this example, you want to multiply this whole bottom equation by -1. Because what's going to happen is when you do that, you're going to get -6c plus 2d equals -12. And now this -6c would cancel out with this positive 6c. So what we did here is we multiplied one entire equation by -1. And our goal when we do this is always going to be that one variable, so either the c or the d, will have coefficients that are the same number with opposite signs. And again, when I'm talking about the same the same number with opposite signs, I'm talking about like this 6 and -6 that are the coefficients on our C's. So now what we have is a new system of equations. We have -6c plus 2d equals 12, and then our other old original equation, 6c plus 7d equals -15. And at this point, we're going to just go along and do our linear combination. So we're going to add these two equations together, and when we do this, we're going to see that very nicely the c's cancel each other out, and so we get 9d equals -27. And so we're solving for d. So we're going to divide by 9, and get d equals -3. So our second step will be to combine equations and solve for the first variable. So this is basically what we're doing in the last example. And then once you have this first variable, it's really easy to solve for the second one. So to solve for the second variable, so we solved the equation that we got after we combined for the d equals -3. And then our third step is just going to be to take this d equals -3 and use it in one of the original equations to solve for c. So by plugging d into one of our original equations, that's going to allow us to solve for c. So if I pick the first original equation, 6c plus 7d, but instead of d, I'm going to put in my -3. So I just need a 7 in there. So 6c plus 7 times -3 equals -15. I know that this is 6c minus 21 equals -15. And I'm going to add 21 to both sides, which gives me 6c equals positive 6 when I added 21. Divide by 6, and we get that c equals 1. So now we have two answers. We've got d equals -3 and c equals 1. So we're ready to be able to write our solution. We can say that the solution is the ordered pair, and we're going to go in alphabetical order since we don't have x, y. We'll do c is 1, so that will be the first coordinate, and then the second coordinate will be d equals -3. So now we have our solution. The last thing to do is check, which I'm going to leave up to you. So you should go and check to see if 1, -3 is actually a solution to this system. And remember, you want to use the equation that you didn't just use to solve for the second variable. So you'll want to use this equation right here, because we just used this to find c. Now you use this one to check. So pause the video for a second and check to make sure that that solution works in this equation. Okay, so hopefully you've taken a minute and gone through this and solved to make sure that that 1, -3 does work in here, and it actually does, so hopefully you were able to see that. And now it's time for you to try one. So for our third example, this is a you try it problem. I'd like you to solve this system using linear combination elimination. And I'll give you a hint, you are going to have to multiply one of the equations by -1 in order for it to work. So take a minute, pause the video, see if you can get it to come out to the right answer. Okay, so if you're hearing this, hopefully you've worked through this problem, done some linear combination elimination, and you're probably saying to yourself, I wonder if I got it right. So here's the big moment. Did you get, for your ordered pair, s coordinate, so I'll do that first, s coordinate 2, hopefully you got that, and then if you had that, you probably have the t as well, t coordinate 3, so you should have st 2, 3. If you did, great. If you didn't, try and go back and see what your mistake is, and if you can't find it, we'll definitely go over it in our next class. So thanks so much, have a good night, and I'll see you soon.